Hello everyone, this is Weber and you are watching the solutions of the quiz 1 that you just attended in the morning session at around 10. So I hope you have all done that quiz and you found that quiz easy and learning. So let me now tell you the solutions so that you can just match your answers. And in case you have not attended that quiz up till now, then first do attend that quiz and then come to this solution wala part. Okay, I hope so I'm clear. Let's move to the solutions. Firstly, we begin with the solutions of section A. Now, as you all know, each section contains 6 questions, but you just need to answer 5 questions. So, while checking your answers, if you found any mistake, then just deduct your marks. And if you found your answer correct, then please give your marks accordingly. So, section A contains each question of 2 marks, while section, and this gives you in total 10 marks. Okay, for only 5 questions. Don't mark for all 6 questions. Okay, let's look at the first question. So, this was the first question given to you, asking you to write the principal value of this term, cos inverse root 3 by 2. This is a pretty easy question. I hope you all have done this. It's nothing but pi by 6. You know that how to do this? Okay. So I'll tell you the solution part that you need to write in the exam, because in exam the question would be like this one. The principal, find the principal part. They will not give you this options, right? So how you will do that? Let's see. So you'll write firstly. Now, whenever this question comes like find this value or the principal value, you first need to show it is defined or not, whether you can write like this or not. And I know how to. And I have told you in the last class how to do these types of questions. You need to check whether this term lies, this x, whatever you have over here, lies in the domain of that inverse trigonometric function or not. For example, here, root 3 by 2, we have this x, and the domain, for the cos inverse function is closed interval minus 1 comma 1, and which basically lies in this domain, right? So that means then I can say that this is basically defined. So first you need to do this. Whenever you have to find any value, you need to first show that it is defined. Okay. Now you move to the principal part. Now from the table that I have shown you earlier, the principal value for the inverse cosine function is this, lies in this region, closed interval 0 comma pi, right? Now just look how we'll do this. Okay. Now this x, for which you have to find the value, this is basically positive and cosine function I'm talking about. The cosine function is positive in first and the fourth quadrant only, right? The cos function is positive in this quadrant and in this quadrant only, and no other quadrant. You can use the rule all sine, tan, cos. Clear? Now your principal value must lie in this interval, that means from 0 to 2 pi, that means from here to here. That means either in the first quadrant or in the second quadrant, according to this. But you know that cosine function is positive only in first and third quadrant. So that means your answer should lie in the first quadrant only. And now you know that cos of pi by 6, that means cos of 30 is nothing but root 3 by 2. So that means cos inverse of root 3 by 2 is nothing but pi by 6, and which is your required answer. Clear? I hope so it's clear, because it's just an easy question. But this is the way that I just want to tell you in this question. First, you need to show, this is the first step. You can do it in steps as well. Like the first, you need to show whether it is defined or not. For the second step, you need to tell its principal part lies in which quadrant or in the which region. For the third, you need to find in which it is positive or negative depending on the question. So here you have to find the value of this positive 3 root 3 by 2. So that's why I'm taking this positive. If it's negative, then I would be considering the negative one. And the fourth step is the final one. You need to find the answer by the trigonometric table. So these four steps you just need to consider. If you have done this, then grant yourself 2 marks, otherwise not. Clear? So let's now move to the second question. The second question was asking you to find the value of tan arc cosec of minus root 2. Okay. Now it looks a bit typical, but actually it's not typical if I just show you how to do this. So let me tell you the answer first. The answer is minus 1 is the answer, and it's actually a very easy question to give you. Well, basically what you need to do, as I always tell you, here also you have this arc cosec, means the cosec inverse of minus root 2. So first you need to show whether it is defined or not. So firstly, what is the it must lie in the domain. Okay. Now for the inverse cotangent cosecant function, its domain is this: minus infinity closed minus 1 union 1 closed 1 open infinity. Right? You remember that you need to write like this, that x less than equals to minus 1 or x greater than or equals to 1. Right? So I can write this thing in the interval form as well. I have told you this. Now minus root 2 is basically less than minus 1. Right? Because root 2 is nothing but, if you just know this, so root 2 is nothing but 1.4. So minus 1.4 is basically strictly less than minus 1. So that means it lies in this region. So that means our cosec root 2 is defined. Basically it's negative root. Negative sign is missing over here. So it's our cosec negative root 2 is defined. This is the first step and the very basic step. Now what you need to do? Now it is basically negative. So in which quadrant cosec function is negative? In the second and in the third. So you're done with this second step as well. Now the third step. The range, or you can say the principal value, that means the same. Right? So for cosec inverse function, it is this. Remember I told you it is nothing but the sine for the tan and for the cosec function. It is exactly the same. That is from minus pi by 2 to pi by 2. Just the endpoints are changed. That is, in sine you have the closed interval minus pi by 2 pi by 2. In tan you have full open interval, and in cosec you have the closed interval. Just you need to also exclude the point 0. Exclude means you cannot take the value 0. Okay, you need to exclude that point as well. This is just the thing. I told you this, and you know the range, because this is very important. Now you have done the third steps as well. So your answer, that means the value you this I'm talking about this only first. This r cosec minus 1. So the angle must lie either in second quadrant and third quadrant by step 2. But by step third, angle must lie between from minus pi by 2 to pi by 2. That means either in first quadrant or in the fourth quadrant. So that means the common region is what? Okay, 1 second. Cosecant function is negative. Oh, it's written actually wrong over here. Sorry. It actually must be fourth quadrant. Yes. Because you have this rule. Let me tell you. This is all sine, tan and cos. Right? And you have this cosec function. So cosec is nothing but 1 upon sine. So wherever sine is positive, cosec is also positive. sine is positive in this first and the second quadrant and negative in rest others. So cosec is also the same. Positive in the first and second and negative in the rest too. So cosecant function is negative in fourth and third, not in second and third. Sorry, this is a mistake. So you write cosecant function is negative in the third and the fourth quadrant. So either your angle should be in this quadrant or in this quadrant by second step. Clear? Now, by the third step, that means from the principal range or the principal value, whatever you want to say, according to that, the answer or the angle should lie in from minus pi by 2 to pi by 2. That means either in first or in second or in fourth. So that means your angle should lie in the fourth quadrant because this is the part that is common to both the answers. Right? So your angle must lie in the fourth quadrant. And now I told you pi by 4 is root 2. Then 0 pi by 4 and then minus pi by 4 is nothing but cos minus pi by 4 is nothing but 1 upon sine minus pi by 4 and which is what nothing but minus root 2. You know that? So that means r cosec minus root 2 is nothing but minus pi by 4. Now this is the angle that you are getting minus pi by 4 in the fourth quadrant. Clear? Now just you need to find the value of tan of minus pi by 4 because this value is minus pi by 4. So tan of pi by minus pi by 4 is fine. Now tan of minus x you know is minus of 10x and tan pi by 4 is 1, so it will be minus 1 and option A is your correct. So it's again an easy question. Just you need to follow the same steps. Firstly, you need to check whenever this inverse is defined, you need to first check whether it is defined or not. Second, you need to write in which quadrant it is positive or negative depending on the given situation. Third, you need to find the principal value lies in which quadrant or the range, whatever you will say. And finally, you just compute the value. That's the simple and the easy steps you need to follow. So I hope so you are done with this question. So if you have done it correct, grant yourself the 2 marks. Otherwise, deduct yourself depending on how much you have done correct. Okay. But if you want to follow my thing, then do one thing. If you have just done something incorrect, more than correct, then don't give yourself partial marks. Maybe the board examiner will give you the partial marks, but right now don't give yourself the full 2 marks. If you have done anything incorrect, just give yourself a 0. Right? So if you get the less marks out of the total, then you will be more motivated. That next time, whenever the quiz would be there, I have to perform better. I have to perform the best. I can't just do the worst case as I did in the previous one, right? So that would just motivate you. But rather, if you get this by not deducting your marks, you get 36 out of the 40. So you will be proud that I'm getting the marks. Maybe you have done it or not, but don't do that. Okay. So if you have done a single mistake, just grant yourself 0, right? Or if you have done full correct, then give yourself full 2 marks. This is my philosophy that I used to do, but the choice is yours, depending on you whether you want to do this or not. Okay, so let's now move to the next question. Okay, so the third question was now this was the question that came to my mind on let you check that whether you get the things or not, and I want to check your knowledge in this question. That's why I given this question. This question is basically telling you that y is a real number, and also this thing is given to you that m is nothing but sec inverse x and which is nothing but tan inverse of y, where what is x? X can either be greater than equal to 1 or less than equal to minus 1. Then you need to tell in which quadrant or in this which region among the 4 given to you m lies. It's just a 2 marks question basically. It's a tricky one. If you know about the domains and the range, then you can easily do that. So let me just tell you the answer first. And the answer is this: open interval 0 comma pi by 2. It's very easy. if I tell you the solution, you would be easily that why you just leave this question in case you left it. So let me tell you the solution. Okay. So as I always told you, firstly you need to, whenever you see this inverse thing, kind of thing, you need to first see whether it is defined or not before proceeding further. So firstly now, it is given to you x is greater than equal to 1 or less than equal to minus 1. So that means second verse x is defined, because this is nothing but the domain for the second verse function, if you remember. Also, y is a real number. So that means tan inverse y is also defined, because this is nothing but, because real numbers, all real numbers are just the domain for tan inverse functions. Okay. So now second verse x and tan inverse are just different. Now second step, first step we are done. Second step, because we don't know about x and y, whether they are positive or negative, so we move to the principal value or the range, you can say. So the range for arc sec function or the second inverse function is this, nothing but this, and for tan inverse function is this. See, I told you sec function is similar to cos function. So for the cos function you have 0 to pi, closed interval. Okay. Then as you move to cot, it becomes open interval 0 comma pi. And as you move to sec, it becomes open 0, closed pi, excluding pi by 2. This is not included, right? And for the tan function, you are just sine function. So sine function is closed interval minus pi minus pi by 2 to pi by 2. And for the tan function, it's just open interval, nothing. So you get this range. Basically, if you get up till this, your question is 100% solved. Just you need to use this given thing. Now, the important thing, just understand this carefully. M is equal to sec inverse x, also equals to tan inverse y, right? You need to find where this M lies. That means what can be its value. Okay. Now, this is equal, so I can take M equals to sec inverse x first. Okay. Now, by this range means the value arc sec function will take, which is nothing but this sec inverse x. That means what would be the value for this x? The sec inverse x will get this value. That means its range is this. That means it can take the angles from open interval 0 comma closed pi, excluding this pi by 2. Let me draw the graph and tell. So this is basically 0. This is pi. This is pi by 2. And this is minus pi by 2. Correct? Now what you need to do. So for the range of sec function, arc sec function is 0 to pi. That means all angles. This is also included. But this is not included. 0 is not included. These are the angles included, excluding the 0. And also excluding this pi. This is also not included. Correct? So that means M will lie in this region only. From 0 to pi, closed pi, not equal to 0 and not equal to pi by 2. Correct? Because it is equal to second verse. Now consider this thing. Let me just remove it. Okay. Now consider this. M equals to tan inverse y. Right? It is also equal. Okay. Now I told you this thing. This is 0. And this is nothing but pi by 2. And this is nothing but minus pi by 2. Right? And this is nothing but pi over there. Right? Just understand. So in the previous part, angle was this, not including this, and not including this. This can be included. Now what if m equal to tan inverse y? So then m must lie in this region from here to here, not including these end points. So it is all not included and this is also not included, right? Now these are both equal. That means m must satisfy this range also and this range also. So what is the common range that m can satisfy? Because if m lies in this region, then m did not satisfy the tan inverse y region. And if m lies in this region, that means this fourth quadrant, then m did not satisfy the range required for the sec function, arc sec function. So the common range must lie in the first quadrant only. Because for that m will satisfy both of the ranges and it can be equal to both. Now what to include and what to not? Just see this carefully. So I can directly cut up till this explanation. I can directly cut 0 to pi because this second region is not included now. It is not included. Fourth is also not included. So I can cut a part also because it is saying from minus pi by 2 to pi. Okay, similarly I can cut b region also because it is also from minus pi by 2 to pi 0. That means fourth region. So directly your answer is D. But let me tell you how to find the common region. So for the common region, you will take all the angles that satisfy both of the ranges. Now let's take 0. So 0 is not in the arc sec function but lies in the arc tan function. So 0 is not included because it is not over here. So we will take that is common to both. So we will not take 0, that means it will be open 0. 0 open. Because it lies in the first region only. The angle should be from 0 to pi by 2 only. Now whether to include the end points, that means 0 and pi by 2 or not, we'll see. So 0 would not be included because it does not lie in this arc length function in the range while it lies in this, right? For 0 will be included if we have this closed interval over it. But we do not. We have the open interval. That's why 0 is not. It is not common to both. Now, pi by 2. Pi by 2 is not included here and not included over here also. So we do not include pi by 2 as well. So it's just open interval 0. Pi by 2. Clear? It's the simplest and the easiest question in the whole question paper. It was just set in order to tell your knowledge, how much you know, how much you can play with the range and the domain concept. Okay, so I hope up till now you are somewhat clear more about range and domain and how to look at the things. Right? In case of any further doubt, then please drop your query in the comment section. Okay. So let's move to the fourth question. The fourth question was given that x is equal to arc sec minus 2020 by 2021, then what is x? Is it pi by 2? Is it minus pi by 2020? Is it 2021 pi by 2020? Or is it not defined? I hope so you have done this question. This is also easy one. And the answer is the D. It is not defined basically. You can clearly look at this. I have already told you whenever you have this inverse, you need to first check whether it is defined or not. Now, this minus 2020 by 2021. This is basically less than 1 because it's negative, and it is also greater than minus 1 because whenever you have the numerator less than the denominator, it the thing is would be less than 1 only. So it would also less than minus 1, right? So that means this arc sec minus 2020 by 2021 is not defined because this number basically at which I am finding this inverse, it does not lie in this range or the range or the principal value required for the arc secant function. So not in the range, basically in the domain, right? Not lies in the domain. We have the domain for the second function is this only, na? X less than equals to minus 1, right? Which is nothing but open interval minus infinity comma closed minus 1, or x greater than equals to 1, which is nothing but closed 1 and open infinity. But this value lies in the middle, which is not over here. So it's not basically not defined. This rx sec minus 2020 by 2020 is not defined, which is nothing but x. So that means x is just not defined. This is also an easy trick. Now here any value can be given to tell you. It can be like 4 by 5 or is that, because 4 by 5 is also less than 1, right? So just need to simply use the domain concept over here. Clear? Let's move to the fifth one question. Okay, so now this fifth one question is a bit using this property that I just told you in at the paper time. This property I have not uh, studied, taught you up till now, but we'll look at this in the coming classes. I gave you this question just to tell you that you have to use this property, that you must know how to use this, right? But I hope many of you have left this question in the choice. If not, then very good, and we'll proceed to the solution. So first, let me see the answer. Answer is just 1 by 5, and we'll see how it comes. Just you need to use this property, nothing else. Rest is just the simple things that you do. Firstly, sine inverse x, this is defined or not, we'll see. Because x here we don't know what is x, we need to find it. So we can't just say whether it is defined or not, we'll see after finding the value. So we can verify whether it is defined or not. So minus 1, 1 by 5 belongs to the closed interval minus 1, 1, which is nothing but the domain for the inverse sine function. So basically sine inverse 1 by 5 is defined. The first step is complete. Now you can see that we do not know the value of sine 1 by 5, that we do not know the angle alpha at which sine is different. Sine has the value 1 by 5. So what to do then? So we'll do something else. Okay. So we have this given equation, right? It is sine of alpha equals to x. I taught you this thing. You can take it like this. Sine of alpha equals to x. So alpha can be written as sine inverse x, right? We can do this. Now, sine inverse 1 is defined because 1 lies in this closed interval, and you know its value is pi by 2. Clear? Then sine inverse 1 is different. Okay. Now, sine inverse 1 by 5 can be written as equals to, so you just take this cos inverse term over there. So you will be having pi by 2 minus cos inverse x. Now use this property. Okay. Now we use this property that sine inverse x plus cos inverse x equals to pi by 2. So that means if you just take cos inverse x over on the right hand side, you will be having sine inverse x as pi by 2 minus cos inverse x. So you can write sine inverse 1 by 5 as sine inverse x. So that means x would be 1 by 5. Clear? As simple as that. Nothing you need to do. You need to first apply the definition, which I taught you in the first class, in the second class basically, and then use this property, and then you are done with x equal to 1 by 5. Okay, so in case you have also left this question, then no problem. We'll do it when we'll be discussing this property for the inverse trigonometric functions. Okay. So I hope this question is clear to you. It's just easy. Let's move to the final question for section A, which was this easy question. It was something that I told you in the last lecture, that find the value of cosec inverse minus 1 plus cot inverse minus 1 by root 3. So we'll proceed with the first thing first, as I taught you. The answer is C. It's pi by 6. Okay, in case of any doubt, please see the solution. So firstly, we'll again check whether these are defined or not in order to proceed. Because if I gave you something that is not defined, then you can't tell the answer. Then you will be saying that all of the options are incorrect and it is answer is just not defined. Right? That I gave you many times a question like this as well. In the set form and in something like that. So first you need to verify that, because in exams you don't have these questions coming. You just have the theoretical ones where there is no options given and the answer can be not defined as well. Okay, so it's better to first verify whether it is defined. Now, minus 1 lies in this domain, and which is the domain of for the inverse cosec function, right? So that means cosec inverse is defined, no problem. Now, minus 1 by root 3 is a real number, because domain of cot x is a real number, na? All real numbers. So it is a real number. So that means it is also defined. So we are done with the first step. Now second step. Cosec function. Look at this function. It has this value negative 1. It is asking. Na? So when cosec would be negative? Here it is written correct in the third and the fourth quadrant. Right. So this is basically the second step. Third, the principal value is same as sign, just excluding 0. That is closed minus in closed interval minus pi by 2 comma pi by 2, excluding this 0. So third step is also done. Now finally you just need to find the value. And now you know in which quadrant your angle should lie. According to the second step, it must lie either in this quadrant or in this quadrant. And by the principal value, it must lie in this first or in third. So that means it must lie in the fourth quadrant only for the common. Because you always take the common thing, that you can take both. Right? That satisfies both of these conditions. So it must lie in the fourth quadrant. And you know, cosec of minus pi by 2 is 1 upon sine minus pi by 2, which is nothing but minus 1. Which is this. So what can I say then? I can say that cosec inverse minus 1 is minus pi by 2. Done. So first part is done. Now look for the cot function. We have told you that it is defined. So let's now move to the second step for the cot function. It is given negative 1 by root 3. It is given to you this thing. Yeah? Now cot is negative in which quadrant? In the second one and in the fourth one. Rest it is positive. And the principal value is the third step. Principal value is open interval 0 pi, because cot is exactly the same as cos. Just the open interval comes. So now here also you know in which quadrant the angle should lie. According to the third part, angle must lie either in the first or in the second. But according to the second step, it must lie in the second or the fourth. So the common is second. The angle should lie somewhere over here, and it's nothing but 2 pi by 3, which you can find that cos 2 pi by 3 is cos 2 pi by 3 over sin 2 pi by 3, which is nothing but minus half by root 3 by 2, and which is nothing but minus root 3 by 2. That's the desired answer. So thus cot inverse minus 1 by root 3 is nothing but 2 pi by 3. Now after finding these both angles, you just need to find this. That means you just need to add them. Adding them, taking the LCM, getting the answer as pi by 6. That's easy. So I can say basically now that section A was very easy. There was not even a single question that requires some heavy calculation. I know that section B is a bit lengthy one, and it requires some calculation part, but section A is not like that. It's a bit easy one, and I hope so you also have find it easy, right? So this ends the section 1 answer, and I hope so you have done all these questions, checked all your questions, and cleared all your doubts. Further, if you have doubts, please mention in the comment section. I'll consider that doubt in the next video section when it will be posted. Clear? Okay. So let's move to the section B now. Okay. Now this section has some of the questions that require some calculations. Otherwise, it's also very easy. So the first question on your screen. Okay. It basically asks you whether find A is positive or A is negative. Just this, but you need to use this domain and the range concept for the inverse function. I already told you in the exam only that you don't use this fact that it's square over here and it's square, so both these are positive, so their sum must be positive, so answer must be this. Definitely the answer is this only, that is rectangular, but you don't have to use that thing. You first have to use the concept of the domain and the range. Afterwards, you can use this thing if you want. Okay. Firstly, first comes first. We'll look at the domain and the range. So it's inverse. So we'll see whether it is defined or not. Now, 2 and 3 both are real numbers. You know that. So basically, that is just the domain for tan inverse and cot inverse. So tan inverse 2 and cot inverse 2 are both defined without any problem. They are defined. Okay. Now, second step, the principal value. Because we don't have to find the value here, so we are not using where it is positive in which quadrant, or because we don't know in which quadrant it is having this 2 value. We don't have that angle right now. It's not given in the trigonometric table as well. Okay, so what we're gonna do, we will now find the third steps first. So we'll find the principal value for the arctan function lies in this open interval minus pi by 2 pi by 2, and for the arccot function is open interval 0, which I already told you how to find it, how to learn it. Already told you in the previous lecture. Okay, now 2 and 3 are both positive. Now, the trick that I am using over here, I have told you in the last table that I have shown you of the principal values. There, the last two columns. The last two columns, I have told you that please remember these are very useful, and also told you the trick how to remember them. That for x greater than or equal to 0, what would be the range, and for x less than 0, what would be the range. Okay. So I'm using that result over here, because these would be beneficial over here. Okay, so 2 and 3 are both positive, so the last second column you need to use. So that means now the domain for the tan inverse function would be closed 0 open pi by 2, and for the cot inverse function would be open 0 closed pi by 2. Okay, so you need to first do the sec of this tan inverse function. Whose range is this? Positive. So sec of any this function, or here cosec of this function whose range is this, it would always lie in this, because this is basically the range for the cos and the sec function, less than equal to minus 1, greater equal to 1, right? And which is nothing but the domain for the inverse cos sec and cosec function, right? So it can either be negative or can be positive. Okay. If it is positive, that means it both the values lie in this quadrant, then A would definitely be positive. If they are negative, then also A is positive because of this square term. Then use this concept that because of this square, the answer would be positive. So that means the answer would be A, which is nothing but positive 1. This just proves the fact. Okay. And basically, let me tell you, this is your previous year board exam question, ISC board question, and it comes in the previous year board examinations. There you need to prove that this has a value 15, but I have not told you up till now that how to do these types of questions, like manually how to find the angles, right, without using the tables, and how to proceed. So we'll take this thing in the later classes. Okay. So I just want to check whether you know the domain and the range concept to be more clear, because this quiz is basically on the domain and the range. The principal value is how to find that. These are most important things, the very basic things that you must know in order to further proceed for the chapter. Okay. And in case you have not watched that lecture up till now, please go through the video section and watch the third lecture on the series inverse trigonometric functions. Okay. So this is just the thing how you need to proceed with the domain and the range concept, and I hope you have done this thing in your answer sheet only. If not, then you know how to do this now. Okay, I hope so you are clear. In case of any doubt, please mention the comment section. Let's now move to the question number 2. So question number 2 was also easy. It was telling you, giving you two equations and you need to solve them. That means finding the value of this x and y. And also hint is given to you, that means again you need to use a simple fact that sine inverse of some a plus cos inverse a would be pi by 2. It was 6 marks question. Each question in part B is of 6 marks and you need to attempt 5 questions. So in total this can consist of 30 marks. So grant yourself the mark accordingly. Okay. Now you have to use this hint to solve this equation. This is very basic and easy to do this. So firstly what we will do, we will convert the equations in the same form. Either whole of the equation will be cos inverse, or whole of the equation will be sine inverse. You can do anything. Either you convert this equation in sine inverse using this inequality, or you convert this. I have converted this into cos. So this is given to you. Now, in place of sine inverse x, I can write pi by 2 minus cos inverse x. And in place of sine inverse y, I can write pi by 2 minus cos inverse x using this, the equality that is given. Because sine inverse is pi by 2 minus cos inverse x. That's why this x and y inverse. And this is nothing but 2 pi by 2. Clear? Now, this would be minus, take out common. We would be left with cos inverse x plus cos inverse y. And just sending pi by 2 plus pi by 2 is pi. Sending the pi over there, so it's 2 pi by 3 minus pi. Right? Now it is minus over here. Send it to that side, so you will be having now this equation. Cos inverse x plus cos inverse y equal to pi by 3. So now you have the two equations in the same form, in the cos inverse form. Now you can easily solve this. So just add both the equations as you always do to solve the simultaneous equations. Adding both the equations, this cos inverse y term would get cancelled, and you would be adding 2 times cos inverse x as pi by 3 plus pi by 3, which is nothing but 2 pi by 3. Clear? Now I can write cos, taking this 2 over here, so 2 to cancel. So cos inverse x will be pi by 3. And now using the simple rule that I told you, at what angle alpha the cos would have the value pi by 3, at oh not like that, sorry, you can take cos over here. So cos of, sorry, it's written something wrong. It must be inverse over here, because cos inverse of half is nothing but pi by 3. You can see that cos at pi by 3 is half. So cos inverse half would be pi by 3. So then x can be half. Okay. Now to find y, you just what you can do, subtract the equation, or you just put the value of x in any equation. You can do anything. Suppose I put the value of x in this equation. So cos inverse half plus cos inverse y will be pi by 3. That means cos inverse y will be 0. How you are getting 0? Cos inverse half is what? Pi by 3. It is also pi by 3. When pi by 3 comes up here, pi by 3 minus pi by 3 will be 0 only. Okay. Now at which value you have this angle 0? You know that this is inverse. Oh, this is not inverse. So cos of 0 is nothing but 1. So that means y would be 1. Just you need to take the trigonometric function over here and find the value of x. Like here, cos inverse x equal to pi by 3 will become cos pi by 3 equal to x. And here, cos 0 would be y. So simply you get x is half, y is 1, and which is the solution for the simultaneous equation. So very easy, and the hint is always given to you. You always need to use the hint. Either you convert this equation to cos or this equation to sin. Any one thing you do. I convert this to cos. You can also convert this equation to sin and then proceed. Again, you will get the same answer as half comma 1. Try that at home, and in case of any further doubt, please post it in the comments. So let's now move to the next question. Okay. The third question was given to you, that if arc of cot of minus 1 by 5 is nothing but x, where this x lies between 0 and pi, then you need to find the value of sine of x and cos of x, and each part is of 3 marks. Now here, you need not to given over here x from 0 to pi, because you already know that the range for cot inverse function is nothing but lies in 0 to pi, right? But if it's given, then well and good. Now, using the simple trick. Now, let me first tell you the thing. Here, you would not do the thing that basically here the first step is missing. I have not written over it because I know it's very basic. Now you know how to do it. Firstly, you need to tell whether cos inverse 1, cot inverse minus 1 by 5 is defined or not, which is defined because it is a real number, and the domain for cot inverse is nothing but the real number. First step is that. Now you would not do that in which quadrant it is negative and what is the principal end, because you don't know any angle whose value is, whose cot is nothing but minus 1 by 2. This is not the normal value that you use. So for that, what you will do? You will take the cot from here to here. So that means you will be having minus 1 by 5 equal to cot of x. So cot inverse would become just cot, right? Now use the trigonometric identity. You know that cos inverse x minus, sorry, cosec square x minus cot square x is 1. Then cosec x would be 1 minus cot square x power half. Now you know the value of cot x. Use it over here. Solve this and you will get this value for cosec x. And you need to find the value of sin x. Now, sin x is nothing but 1 upon cos x. So sin x is nothing but 5 upon root 26. Easy. Now many of you thought in this question that you have to first find the value of x, then put the value of x over here and then solve because of this domain. No, you can't do like this. You don't know at which angle, na? It's minus 1 by 5. So what you'll do, you just take this r cot over other side and make it cot. and then use the trigonometric identity to find the value. Yeah. Okay. Now for the cos, you will use this identity. The cot of x is cos x by sin x. You know the sin x from here. So using that implies cos of x will be cot x into sin x. Now cot x is given to you. Sin x you just find. So multiplying you will get minus 1 by root 26. This is basically a super easy question in this section. If I just say. Okay. Just you need to use this and nothing else. So I hope so you have done with this question as well. And grant yourself 6 marks if you have done correct. Otherwise grant yourself a less 1 mark. Like you can grant for 3 marks. If you have done some mistakes, if you have done nothing, grant yourself a 0. And basically, I must say, if you have done nothing or just a single mistake, then also you will grant yourself a 0. Because at last, they should bring your fire in yourself to prepare more and to get the best for the next day. Let's now move to the fourth question. The question was, now, it was a question from the chapter Relations in the Functions. And basically, the topic up till now I have covered in the first lecture. So it's basically up till that on, not anything else. Okay. So the set was x comma y pair. X is a rational number. Y is an irrational number. Then you need to find whether it is a relation or a function or both. Okay. Now, those of you don't know what is a rational and irrational, let me first tell you that. I hope you have known these facts because it's just the basic. So basically, a rational number is of the form p by q, right? Where p and q both are integers, either positive or negative, doesn't matter. So I can represent every rational number in the p by q form. For example, I can write 3. It is basically a rational number. I can write 3 is equal to 3 over 1. Right. Similarly, I can write 6 as 6 over 1. Or I can write 6 over 1. Or I can write it like that 12 over 2. This I can also write. Okay. So this is a rational number. Irrational number is which can't be expressed in this form. Okay. Which can't be written in the p by q form. And no. That is an irrational number, like square root of 2, or it is the square root of 3, right? Because if you want to write like this, root 2 by 1 or root 3 by 1, you can write like that, but then root 2 would not be an integer, root 3 would not be an integer, right? So this is basically rationals and irrationals. So now it is considering all the pairs where x is rational and y is irrational, and you need to find the relation. So clearly it is a relation because it is a set consisting of ordered pairs. No problem in that. Now, it is interesting to see whether it is a function or not. It is not a function, right? Many of you have got confused in this question, might be. Okay, so let me just tell you the reason. This is just example you need to form. You can take any example. So, 2 is a rational number because 2 can be written like 2 by 1. While root 2 and root 3 are irrational because they can't be written like p by q form, right? Where p and q are both integers. Now consider this pair 2 comma root 2 and 2 comma root 3. They both lies in S because these must lie in S, right? Because this 2 is rational, root 2 is irrational. 2 is rational, root B is irrational, and this is basically the definition how the pairs are defined in S. So that means I can find two distinct ordered pairs whose first component is the same and which nullifies the property for the function. So that means S is not a function because of this example. Now you can construct any example, whichever you want, just be it perfect. You can also take 5, 6, 7, any rational number and any irrational numbers on the other side which are different to make a contradiction or to just oppose this function definition. So thus S is just a relation, not a function. It was just an easy question, not of 6 marks, but I still gave you the 6 marks very easily. Okay. Now let's move to the fifth one question. Now this was a bit tricky one. I must say this was a bit lengthy one also. So in case you have just left out in the choice, then that's not an issue. You can perfectly do that. So here you need to prove that this thing equals to 2b by a, whatever is given to you, this big one term. And I also gave you the hint at the paper time that you can use the fact of tan of a plus b and tan of a minus b. You can use the formula and proceed. And also the hint that you can let this term as p and use the trigonometric identity. So this hint would be just beneficial for you in order to proceed. Okay, so let me just use the first hint that I let cos inverse of a by b as p. That means I can take cos on that side, so the cos p would be a by b. Okay, so now according to the question, this is given to you. I can replace cos inverse a by b on both sides by p. Because of this, it will be p, it will be p. Okay, now using this formula for tan of a plus b and tan of a minus b. So tan of a plus b is tan a plus tan b divided by 1 minus tan a into tan b plus, what is this? This is basically tan of a minus b, a minus b, whose formula is tan a minus tan b divided by 1 plus tan a into tan b. Clear? This is just the easy thing I am telling you. Okay. Now, you know that tan of pi by 4 is 1. So just putting the value. So it would be 1 plus pi by 2 divided by 1 minus pi by 2 plus 1 minus tan pi by 2 into 1 plus tan pi by 2. So up till now the question was a bit. Now you have two terms in, just you will take the LCM and you will be having this thing. On taking the LCM, you will get 1 minus tan square p by 2, and in the numerator you will be having 1 plus tan p by 2 ka whole square plus 1 minus tan p by 2 to the whole square. Now just open the whole square terms. Cancelling the terms, you would just be left with 2 into 1 plus tan square p by 2 divided by 1 minus tan square of p by 2. Alright. Now what you can do, take 2 as outside and just take the numerator in the denominator. So that means writing this as 1 upon 1 minus tan square p by 2 divided by 1 plus tan square p by 2. And again using the trigonometric identity, if you know this, you must have known that this is nothing but cos of p. If you know this trigonometric identity, well and good. Otherwise you have to complete and write it like this one, so that you can use the value that is given to you, that cos of p is nothing but a by b. In order to use this value, you convert it in this form. Correct? Now just put the value, so you'll be having the answer 2b by a, which you need to find as proved. Easy question, I must say this also, because I have given sufficient hints to you that you can use the trigonometric identities and what you need to let. Basically everything is what is given to you in the question. In case you have left this question, not an issue. In case you have done, very good. You have learned the trigonometric identities and you have known these things, then very good. So let's now have the final question for section B. This was the question. Okay, this is again the question from the relations in the functions, whichever I taught you in the lecture first. It was showing you a set x comma y such that y is grandchildren of x. Okay, y is grandchildren of x means you can say that x is the grandfather of y. Also, it can be written like that. Then you need to find whether m is a function or not. And if it is a function, then is it a many one function? And you need to justify your answer. It's a 6 marks question. Okay. So firstly, it is clear that it is a relation. You need to give the reasoning that it is a set which contains the ordered pairs. Clear? But it is not a function again. Why? Okay. So let's understand with a graph, or you can say. Let me have a couple X. Couple means a pair of husband and wife. You can take like that because it's saying Y is the grandchildren of X. So you can take either X as a man or as a woman, or you can take X as a denote a couple basically. Couple means a pair of husband and wife. You can take that thing as a single one. Just for the clarification purpose. So you take a couple X. Okay. So now it has a grandchildren one. That means a grandchild one and another grandchild two. Both are different. The different colors denote that they are different as well. It can happen that this couple has two grandchildren or two grandchildren. It's one and it's one and two. It can have this thing, right? It is not that it can have just one grandchild, like in the case that we did in the class, the example of husband and wife. So there it is for sure that husband can't have two wives and wife can't have two husbands. In that case, it was clear. But here it is not having that condition. A couple or a husband and wife pair, or you can say a single one person, can have two grandchildren or can have two grandchildren and can have more than that as well. That's not an issue, right? That means we have a pair, two distinct pairs that have the same first component. It is the case over here. And when we have this kind of thing, we say it is not a function. Because for a function, we do not want these kind of things. Right? So if it is not a function, then how can it be a many one function? If it's not a function, then it can't be a many one function. We cannot talk about its many oneness. It's not a function. That means it is not a many one function as well. This is the reasoning that you need to show. And I have drawn this diagram. You can even draw this diagram and explain your thinking that a couple can have a grandchild 1 and also can have grandchild 2. So that means we have this pair, two different ordered pairs, couple comma grandchild 1 and couple comma grandchild 2, which have the same first component, same couple x. Right? You can also take this grandchild 1 as y1 and grandchild 2 as y2 in order to denote it in pairs. So you would be having the first pair as x comma y1, where y1 is the grandchild of x, and second pair you can have x comma y2, where y2 is the grandchild of x. Right? So this question is also done. It is a relation just and not a function. Now in case the question was something like that, it is a function, then you need to verify whether it is a many one function. And I told you how to do that. Many one function means many points have the same image. That means they map to just one image. That is the condition for many men. Right. So if that thing is true, then you would say yes, it is a many function. Otherwise, it is not. We'll see the more criteria how to classify them as many functions and one functions in the chapter when we'll be dealing the chapter relations and functions. But up till now, you just get this thing criteria clear in your mind, right? And we'll be dealing with this more detail when we'll be studying the chapter relations and functions. So I hope these questions, the quiz questions, will be clear to you, and the concepts are now more clearer to you than the previous ones. In case of any further doubts, please put down your comments. And if you have not watched any of the lectures, then please do watch it. The lectures are in the video section of this channel. Please go through those videos first. Also, in case of any further clarification, go through the videos. Everything is being provided in the videos. Just you need to listen and watch it carefully without skipping it. Clear? So with this note, let me just end this session now. If you find this video helpful, if you have learned something, then do like this video, share this video and subscribe the channel for more such updates and the notifications whenever I will be putting more lectures on the topic university functions. Okay. So your next lecture would now come up on the 10th of August. You can watch that lecture. That would be an important lecture on the properties of the university functions, and we would also be considering some of the examples from that chapter only. Also, as I told you, I am following the book by Aston Publications written by O.P. Malhotra. If you want me to follow any other book, please do let me know in the comment section so that I will be following that book. And also put down your suggestions in the comment section that what are your thinkings about this channel, whether you are liking the videos, whether you are liking the notes. Okay, so what are your thoughts, what are your feelings? Just put them all as your suggestions in the comment section. Okay, and it's my request, just please subscribe this channel, like this video and share this video to as much as you can so that it can benefit to all those who are preparing for their boards and want to master the mathematics, right? For all those, it's very beneficial, right? So with this note, let me just end this session now. So see you soon on the 10th. We'll be having the next lecture. Don't forget to watch it and don't forget to subscribe the channel for the notification. And please do press the bell icon. Okay. So let's end this session. Thank you.